Hello, everyone. Thanks for coming. This is a great turnout. My name is Jeff Brock. I'm the chair of the mathematics department here. And I'm pleased to announce the Data Science Initiative lecture series, of which today's lecture is the first. Before I introduce the speaker, though, just to fill you in a bit, this will consist of 5 lectures. And we have 4 exciting speakers next semester. On the 18th of February, we have John Lafferty from the University of Chicago. The 14th of March, Raghu Ramakrishnan from Microsoft. On the 15th of April, we have Gunnar Carlson from Stanford and IASTI. And on the 28th of April, the concluding lecture is Giuliana Fieri from NYU. So today's speaker, well, let me just say a bit about this data science initiative. This is emerged from a planning process involving the chairs of 4 departments, Bjorn Sandstede from Applied Math, Konstantin Gatsanis from Biostatistics, Urs Tentemel from Computer Science, and myself. It came out of a rapid planning group convened by Vicky Colvin last year, with the assistance of Jill Pfeiffer, Ellie Upfall, Joe Hogan, and Govind Menon as well. And we've been meeting this semester with the assistance of Janet Bloom and Joe Mizell to put together a proposal for a data science initiative here at Brown University that will establish a presence in data science emphasizing teaching and research, foundational methodologies in data science, as well as outreach to domains represented across the campus. So we're very pleased to see this moving forward, and today's speaker is a great example of the synthesis of all these different ideas. So Chris Wiggins from Columbia University is an associate professor of applied mathematics, and he is also, somehow, manages to be the chief data scientist for the New York Times. At Columbia, we've been asking him how he manages that all day. At Columbia, he is a founding member of the Department of Systems Biology and the executive committee of their Data Sciences Institute and the Institute's Education and Entrepreneurship committees. He's also an affiliate of Columbia's Department of Statistics, a founding member of Columbia's Center for Computational Biology and Bioinformatics, C2B2, and he's a co-founder and co-organizer of HackNY, hackny.org, a nonprofit which is, since 2010, organized once a semester student hackathons, and the Hack NY Fellows Program, which is a structured summer internship at NYC startups. Prior to joining the faculty at Columbia, he was a Courant Institute instructor at NYU and earned his PhD from Princeton University in theoretical physics. In 2014, he was elected a fellow of the American Physical Society, and he is a recipient of Columbia's Avanesians Diversity Award. So please join me in welcoming Chris Wiggins, who will speak on data science at the New York Times.
Thank you, Jeff. Good, and I think this is live. Thank you very much. So thank you, all of you, for making time on a Friday afternoon to come out and hear a little bit about the way we're thinking about data science at the New York Times. As advertised, I'm Chris Wiggins, and I'm splitting my time between Columbia and the New York Times. And I hope you can see I assembled some references from this talk if you'd like to look at references at a bit.ly short link. So first let me say a little bit about data science as the way I'm thinking about it and where data science comes from and what it wants from us. You may have the feeling that data science just sort of came out of nowhere, that all of a sudden everybody's talking about data science all the time. Why? And this is a Google search to put some data behind that feeling. This is a Google Trends result. Something magic happened around 2010 or so, and suddenly there's a lot of data science happening around here. And there's 2013, 2015, just seems to be going crazy. And one of the things that's also happening around data science is jobs. One of the things that drives a field is when suddenly somebody starts putting a lot of resources into a field, it suddenly focuses everyone's attention on the existence of that field. I got the laser thing. Yeah, I figured it out eventually. Thank you, though. The laser. So it'll focus people's attention on a field if suddenly you start saying, I'm hiring anybody who raises their hand and says, I do data science. You bet a bunch of people are going to raise their hand and say, yeah, I do that thing. For example, this guy, so this is an article from last summer from the New York Times, which is a newspaper, and it's saying that this guy went from being a waiter somewhere to getting $100,000 a year just for being a data scientist after spending, 6 months or 12, he spent like 12 weeks at some boot camp, and all of a sudden he went to 6 figures. And as somebody pointed out to me when I gave this talk here last summer, and somebody pointed out, actually he majored in math as an undergraduate at Chicago, so he had a good start. So what is this data science thing, and where does it come from? Well, I think there's a very instructive diagram from 2010, which is ancient history now in data science, by my friend Drew Conway, who's a data scientist in New York. And he synthesized the discussions that were being had in New York City around data science by saying data science is the combination of mathematical and statistical knowledge, hacking skills, and by hacking skills he means it in the original sense of the word hacking, like a creative solution to a technical problem, not breaking into things. Combining those skills with some sort of substantive expertise from a domain. And that's the way I think about data science, is the ability to use machine learning methods to answer a problem from the real world. And that problem from the real world might be coming from, say, the natural sciences or the social sciences, and that's what you see quite a bit in data science and academia, or that problem may be coming from business. And so frequently if somebody hires you as a data scientist in industry, it's because they have some business problem or some problem associated with running a company, which can be reframed as a machine learning task. And I'm going to illustrate some examples of how, both in my prior work in academia and at the New York Times, we try to reframe questions from a domain as machine learning tasks. Going even further back into the ancient history of data science, if you want to see how data science started being used as a job description in tech companies, there's a great essay on this subject by Jeff Hammerbacher. Jeff Hammerbacher is credited with building up the data science group at Facebook. After he left Facebook, he had some time on his hands, and he made this collection of essays, one of which was an essay called The Rise of the Data Scientist. I know it may be hard to believe if you've never heard of the phrase data science, that people were using this phrase way back in 2009. And he says, at Facebook, we felt that traditional job titles such as business analyst or statistician or engineer and research scientist didn't quite capture what people were doing. People were, they might be doing a multi-stage processing pipeline in Python. They might be doing hypothesis testing, regression. They may be using R. They may be designing and implementing an algorithm. They might be using Hadoop, which, I don't know how many people know Hadoop, but like in 2009, this was an early Hadoop thing to do. Or communicate the results. And that's an important part. I'm glad that Jeff said this. Part of being the data scientist is not just reframing the question as a predictive analytics task, or getting your Hadoop on and making sure that you can grab the big data and shove it into a data table. It's also the ability to communicate those to real live human beings who sometimes don't speak calculus. Right? So the ability to interact with somebody from a different domain and really put machine learning tasks to work also includes the ability to communicate to communicate those results in a way that's interpretable and actionable to a real live human. So data science, there's an ancient history to that, right, from way back in 2009, but I want to show you in our time together that data science is built on roots that go even further back than that. So even before 2009, the word data science is being used, and in particular, there's this great essay by the heretical statistician Bill Cleveland, who was at Bell Labs. In 2001, Bill writes this article about the gap between statistics as it was done at Bell Labs at the time and statistics as it was being taught in academic departments. He looked at statistics happening in academia, and by 2001, there was a clear gap between statistics as it was done in the stats group at Bell Labs and as it was being taught in academia. And so he said, data science, an action plan for expanding the technical areas in the field of statistics. Now, where did Bell Labs get this weird mindset about what statistics meant that was so different than statistics being done in academia? How many people know this guy? Almost nobody. Homeschooled guy. Then he went to Brown, got a bachelor's and a master's at Brown. Anybody know him? Only the data scientists. Then he went on and got a PhD in topology. It's a crazy thing to get a PhD in. And then World War II happened, and World War II basically turned him into a statistician. And I think that's an important point because he came to statistics via very applied work, namely warlike work, not like the mathematical statistics tradition of Jerzy Neyman and other people from Berkeley at the time. Gives the word bit, gives the word software, Invented the FFT. Tukey. John Tukey, thank you.
It's a very young picture.
A very young picture of Tukey? Yeah. I'll take that. This is John Tukey telling you what time it is. Called the progenitor of data science by my data mining consulting friend in New York City, Max Strone. The roots, the intellectual there on which data science stands, I think comes from a tradition of heretical and computational statistician that goes way back. It goes back long before 2009. And in particular, go back and read John Tukey's essay from 1962, The Future of Data Analysis. It opens with an amazing sentence. It says, "For a long time I have thought I was a statistician, interested in inferences from the particular to the general. But as I have watched mathematical statistics evolve, I have had cause to wonder and to doubt." It's a great long essay about the difference between statistics as he understood it, the science of data, the ability to make sense of data that the world hands you. It just hands you observations. The world does not hand you distributions. It's a messy place, the world. And the divergence between that and the sort of confirmatory statistics that was dominating mathematical statistics as an academic enterprise at this time. Right? At this point, the National Science Foundation was only 11 years old. Right? The National Science Foundation, in its wisdom, had put probability and statistics as a subdiscipline of mathematics. Right? This is before computing had sort of just happened. Right? Because data are very intimately related to computers because you do not analyze data without a computer. Right? Anywho, I urge you to go back and look at this essay. It's an essay in which he introduces the idea of exploratory data analysis, meaning you found some data from the world, and it's not at all clear. Should I be doing a t-test or a z-test? P-value with respect to what null distribution, right? Or am I even interested in a question where I'm just confirming some hypothesis? How do I make sense of data in the absence of some underlying model? If you look at the way data scientists attack problems now, a lot of that thinking is there in 1962, a long time ago. John is also inspirational because he spent his entire academic career split between Princeton and Bell Labs. I feel like if he could do it then and he didn't even have Unix, surely I can do it. Another thing that Tukey gave us, in 1965, he convened a meeting of people at Bell Labs, including John Chambers, and said, we really should design a separate computational framework for doing computational statistics. And John Chambers thought about it for a couple of decades and eventually created he created S, which later was the inspiration for R, which is now like the weapons grade statistical software used by Google and everybody else. It's free and open source. So Tukey begat S, which begat R. He also did some great work in data visualization. This is a film from 1972 at SLAC, where he introduced a system called Prim9 for looking at data in 9 dimensions. This led to Tukey co-teaching a class in 1975 with Ed Tufte, who went on to create the series of books around visual display of quantitative information. So Tukey begat visual display of quantitative information. If you look at the second edition of this book, it's dedicated to the memory of Tukey. And of course, Tukey himself wrote this book called EDA, which is really fun to look at because he didn't really have a lot of computers to work with. So it's a great book to read because you can imagine him sort of like going between Bell Labs and Princeton, trying to make sense of data without MATLAB, without R, without anything, just trying to make sense of it on pencil and paper. So he begat EDA as an academic field. So keep that in mind as you fast forward to 2001 and this sort of modern article by also similarly heretical statistician. And in this article, Bill Cleveland, who later edited the collected papers of John Tukey, said the primary change agents for the university departments themselves, that is, the departments should change the way they're teaching statistics, and they should teach it letting the data lead and letting computation lead. And you can go on and read reports from the National Science Foundation Statistics Group around 2004 to see that they did precisely not that. And instead, they doubled down on mathematical analysis, which is the subject of a different rant entirely. Today, I'd like to spend some time talking about what we actually do. But I just want to say that the thing called data science has at least 2 deep traditions on which it is building. Like part of why data science is able to catch fire is because there's sort of this slow burn among heretical statisticians, particularly at Bell Labs, starting at least around 1962, and there's sort of a parallel heretic statistician in the form of Leo Breiman. And then it really caught fire around 2009 for a variety of technological reasons. And it's now starting to codify as a job description in the real world, and more recently as an academic description in academia. So, how on earth does this relate to things that I'm involved in? Well, the data pain or the data moment came to biology in the mid-90s when I was a graduate student. So when I went to graduate school, I was very excited about applying the mindset of a theoretical physicist to complex problems from the universe. And a particular source of complex problems in the universe is biology. It's a complete mess if you haven't looked at biology. And when I started graduate school in the early 90s, biologists found modeling in biology to be sort of, entertaining as long as it didn't get in the way of real bench work. And then something happened in the middle of my PhD. This is the cover of Science magazine in 1995. Just so I know my audience, any guesses as to what this is? It's a genome. It's a good guess. Also a good guess of somebody calling it E. coli because it's a circle, so it's got to be a prokaryote instead of a eukaryote. This is the genome of Haemophilus influenzae. It was the first freely living organism to have its genome sequenced. And I can still remember sitting at lunch with some other graduate students, and one of them came in saying, this is going to change biology, right? Because now you have the entire user's manual for a critter available to you. And you've been studying this critter since 1892, and the way you study it is you put it in a petri dish and you pour some bad drugs on it. Maybe it turns blue, maybe it doesn't. Now all of a sudden you have multiple phone books worth of information, and all that information is handed to you in ACGT, GCAT, Tagacat, Gattaca, right? And then you go to your statistician friends, or you open up a statistics book, and the statistics book says, here's the t-test. But you have no idea how to reconcile this abundance of information with a century of bench work and domain expertise about how this critter works. Right? So it was a very painful time in the late 90s. It was very interesting. Suddenly biologists were very interested in talking to anybody who knew how to make sense of data whatsoever. And it was like the wild, wild west. It was like amateur baseball statistics. Just do whatever you want to the data. It was big fun. And so, biology really changed for good, right? That sort of data moment was a big change for biology. You have a system that you think you understand, you've been studying it for a century, and then suddenly you're awash in data, and you do not know how to reconcile those data with the complex system that you've been studying. And part of, I think, what changed there was a change in tool set, clearly, because suddenly you had the tool set of sequencing, and that change in tool set drove a change in mindset. To now you have biology departments where some of the faculty are essentially machine learners. And that, I think, is really what the data science change is you get some change in tool set, and then it forces you to take a change in mindset and thinking about how you learn about this complex system directly from the data. That is something that's influenced my work quite a bit. As one example of a problem I worked on, one of the problems I worked on in 2002, along with somebody from the medical school, was looking at viral genomes and trying to figure out if you could look at a new virus that appears in the human population and figure out if this virus has been evolving in pigs or in birds, swine virus or avian virus. And that may sound like an academic problem, but if you're the government of China and suddenly some new flu is having an outbreak in humans, you have to decide, are we going to kill all the pigs or kill all the birds? So it's not an academic question. So the dominant paradigm, and by academic I mean useless. So the dominant, I'm an academic, so I can say that. The dominant paradigm for this is the one handed to us by Charles Darwin in 1837, which is you should infer the entire phylogenetic tree when you have multiple genomes, and that is really hard. Right? Inferring the entire tree is just a really difficult intermediate problem. But you do not care. Right? You actually don't want the tree. What you want is just tell me if it's from pigs or birds. So we took an algorithmic approach to this, which is to say, could you just build a classifier that takes as input the sequence data, asks a set of interpretable questions that would have meaning to a biologist, and then gives you a score at the end, pigs or birds. Right? You get positive score if you're from pigs, negative score if you're from birds. Just to invoke heretical statisticians again, that paradigm has also been well described by well-trained mathematical probabilists in the form of Leo Breiman, who wrote this great essay about the two cultures of statistical modeling. Are you interested in writing down a generative model from which the data were drawn, or do you not care? Do you just want to generate an algorithm which makes accurate predictions on held-out data? And Leo was advocating that people from the former camp should at least educate themselves in the latter. So that's what we did, and if you want to know more about that, we have a paper about it which you can download freely from the internet, although it also appeared in print later. Anyways, again, the change in data science is really a change in mindset and a change in tool set. So there's the tools that we know, and I invoked Hadoop earlier, or sequencing, or whatever it is that suddenly makes your field data-driven, but part of it is the change in mindset, the idea that I can learn directly from the data without appeal to some sort of model that I'm trying to confirm. How on earth does this relate to the New York Times? So the New York Times is a newspaper. You may have heard of it. This was the birthday of the New York Times. 1851, it first appeared as the New York Daily Times. To give you some sense for where you would put a data science group in the New York Times, I should clarify the org chart of the New York Times. Here is the org chart of the New York Times. Church is where the journalists are. They are the keepers and the defenders of the craft of journalism. State is everything else. So church is where you see awesome data journalism like the Upshot. Upshot team is great. They do great data journalism. I'm not on that team. I got nothing to do with them. I mean, they're friends, but like I'm not on that team. So when I say data science, I'm not talking about data journalism. They are great. They share their code. I urge you to go download their code and check out their work, but that's not my group. Or sometimes I tell people I do data science at the New York Times, and they say, oh, I love your interactives and your graphics. Those people are great, props, but I'm not on the interactive teams or the graphics team. They are in church. I am solidly on state. I'm solidly in the group that not actually producing the journalism, and the things that I do are not public facing. And within state in particular, I am in engineering. And what's happening now is that in media companies, you've had church and state for a long time, and now for the next century, you will have church, state, and engineering, which makes both church and state go, right? The importance of the physical dead tree is lessening every day, and it's more and more becoming a digital enterprise. Now, why would you have an engineering group, and here I mean a software engineering group, in a media company, or at least in a newspaper? And the reason is that it's not just a newspaper. So technology is a story of unintended consequences. One incident that had unintended consequences was the creation of a website. So on my birthday in 1996, the New York Times introduced a website, and they reported on it with the quaint headline, "The New York Times introduces a website." And that has caused lots of changes. So one of the manifestations of those changes is now millions of people every day go and get their news from the website, and millions more get their news from a mobile device, right? So many people's experience of the information that's in the New York Times content is no longer via a dead tree, right? It may be in the palm of their hand, or it may be at their desk while they're bored at work. And what's different there is not just that digital opens up the possibility of new forms of storytelling, which is one of the things that's very exciting about digital, is that now we can have interactives and graphics. For the data scientist, that's not the exciting part. The exciting part is this. When you get a dead tree in the form of a newspaper, the New York Times gets no information about your experience of that dead tree. When you listen to broadcast radio, photons are transmitted to that radio and they get amplified and they go to your ear. The radio station finds out nothing about how you engage with that content. Similarly for broadcast television. It's very different from digital transactions, right? Every time you point, click, scroll, you are making a request, right? You are sending an HTTP request to some web server, and if that web server so chooses, that web server can record what request you have made, which means every time you interact with information digitally, you are actually having a conversation. Some machine somewhere out there is recording every aspect of the way that you interact, right? And that means that instead of having a focus group where you get 20 people in and you ask them, do you like sports? Do you like magazines? Right? You can actually listen to all of your audience at scale, right? So this is a realization for every media company, right? I think for some companies that were born tech, they were like, yeah, of course, we're going to record every event. Right? Like when you're bored in LinkedIn or you're bored in Netflix, the first thing they do is they build a logging system for how are they going to track every event. Right? But for media companies, or for most legacy companies, that was a realization, that there's sort of a change in mindset about what sort of data you get as people use your product. Again, this was a very modern thing. Oh, by the way, I'm not violating any NDA to tell you this. You can open up Google Chrome browser, you can go to the developer tools, and you can go to the network tools, and you can see all of the information that you're sending to any website. So if you ever want to know what data your browser is sharing with people, open up network tools, it'll be big fun. And then close your mind and imagine how much information your Android phone is sharing with Google all the time. So enjoy that. So that seems like a very modern realization that social activities generate large quantities of potentially valuable data. These data were not generated for the purpose of learning. However, the potential for learning is great. This is a statement about data exhaust. Any guesses what year this was written? Any guesses how old this realization is? Good guess. Older. Older. Now you're just messing with me. John Chambers, who went on to invent S at Bell Labs in 1993. So before there was a World Wide Web, right, people at Bell Labs were already thinking about data exhaust. They were already thinking about all the different opportunities to learn from the digital breadcrumbs left by the way that people will interact with the world in the digital, like before the World Wide Web. Right? Bell Labs was really ahead of the game. And then they had trivestiture, and then there was a diaspora, and now we in academia benefit from them releasing in the wild all of these talented people. Anyways, so data science. In 1996, when the New York Times had a website, they're like, oh, the web, that's awesome. It'll be our online presence. And I think that's the way most companies felt about the web in the 90s, was this will be our online presence. And what was realized later by most people, although John Chambers and other people had clearly realized it earlier, is that it is also an incredible microscope for understanding your audience at scale. Those are the kind of data that we're excited about learning from, right? You don't need to ask people how they feel about their product. You can just watch them observe using your product. Also, if your product is code, then it's very easy to send different variants of the product to different people, which is to say, the web is also an experimental tool. Right? It's very easy to serve up different variants of the products to people and to interact with the audience and to interact with the world. So there's abundant data provided for any company that has a website, which is to say, any company. Now, let's talk about unintended consequences. 1996, you have a World Wide Web. 2008, something funny happens in the form of advertising spend. So let's zoom in on this. What on earth is going on? Well, the business of journalism is really the business of newspapering, which is coupled to the income model of advertising. Right? In fact, in the late 90s, you could just give away the New York Times for free because you get so much money off advertising. Good times, starting in 1950, billions of US dollars are being spent on newspaper advertising. Around 2000, everybody's flying business class, good. And then 2004 through 2007, something amazing happens, right? Like if you're a natural scientist and you're studying some system over time and this happens, you're like, that is a signal. Something's happening, right? And this is before the end of the economy, right? This started happening before the economy ended, right? Lehman Brothers and all that, right? What happened was a part of the digital is that you know where people are going and what they're clicking and what they're doing. And this speaks to an old adage in advertising from John Wanamaker. Wanamaker said, the problem with advertising is that I'm wasting half my money and I never know which half, right? So part of the digital is you know which half of your money you're wasting, and advertisers stopped wasting it, right? So there was a huge secular shift about 10 years ago in the way advertisers were spending their advertising. And that meant that the New York Times and every other publisher was suddenly just in trouble from a tremendous loss of their income. So what you have now in publishing and in media in general is we do not yet know, as a species, if there exists a scalable, repeatable business model for journalism. Right? That is an experiment all of us are doing. Whether you're a venture-backed company like BuzzFeed or you're a legacy company like the New York Times, Washington Post, recently acquired by Jeff Bezos, is sort of an entertaining project for him. Nobody knows. Nobody knows if there actually is a scalable and repeatable business model for journalism, which is why every publisher is now a startup, right? So it is not just an academic question to learn, again, useless. It is not just an academic question to sort of learn how people use the product, right? The New York Times and every other digital publisher is trying to iterate, trying to improve, trying to decide how they should build a product with which people engage. By the way, just to drill down on where the money went, where did the money go? Oh, behold and lo, Google. Right? So basically, you can chart like ad revenue, and like over the first half of the last 15 years, it left newspapers and it went to Google, and then more recently to Facebook. So that has been a challenge for the New York Times, and the New York Times has taken it head on to think through what does it mean to innovate. How do you innovate in a 164-year-old company? If you'd like to read about innovation, there's a great report about innovation which a team of 8 journalists put together. And it was reported to senior management in spring of 2014 and promptly leaked to BuzzFeed, which is why we're now able to read about it. Anyways, it's a great document about innovation in general, including at the New York Times. And one of the recommendations was that engineering should play a part in everything. That instead of church and state, which makes sense if you don't want, say, advertisers to be influencing what stories you write, doesn't that sort of separation between church and state makes less sense if you have facets of the company like engineering that are actually powering both the way we tell stories and also the way we run a business. Which is why the New York Times was interested in creating a data science function. So now let me say, that's all background about why you would want to have a data science function. What do we actually do? So I tend to think about, and not only think about, but also explain to stakeholders what we do in terms of the types of learning that we do. I usually describe this learning as either predictive analytics, descriptive analytics, or prescriptive analytics. And those sort of three modelings are the way I try to communicate to people the things that my group does, the things that a business analyst might do, how those relate to the process of the company. These are actually types of machine learning, so don't tell anyone. But when I say descriptive modeling, my head is thinking unsupervised learning. When I say to people predictive modeling, I'm always thinking supervised learning. And when I say to people we're trying to do prescriptive modeling, I'm thinking we're really doing reinforcement learning. So for those of you raised in machine learning, that's meaningful to you. And if not, there's a class that I co-taught on this subject called Modeling Social Data. You can check that out. So let me talk about examples of how you might integrate into company process predictive, prescriptive, and descriptive modeling. Prediction. Why might you want to predict things in a company? Well, the first thing my group attacked was it's a subscription business. And so you can go into some community like a company, you can figure out who are the deciders, you can figure out what are they afraid of, and then you try to build a model that predicts that. So within a few days at the New York Times, it was pretty clear that what people were most concerned about is why are our subscribers canceling when they cancel. So could you possibly just predict which subscribers are going to cancel? So we did that. I was assisted by a Brown undergraduate named Sam, who I hope is here. Sam did a great job. Thanks very much, Sam. So we worked on a series of models to predict various user transitions through what business people call the funnel. Meaning you've got people who are non-readers, and then eventually they become subscribers. They eventually renew, and then some of them cancel. Can you predict people's behaviors at each transition? And why might you want to do that? Well, you can do that for an engineering win and a science win. The engineering win is if you can identify the at-risk individuals, because then you can treat them differently or you can market to them aggressively. The science win is you can figure out the risky behaviors. Can you figure out what they're doing that seems to indicate that they're likely to go? What are the leading indicators for people to churn? So you do that using multivariate statistics. You work hard to build models that are not only interpretable but predictive. Not only predictive but interpretable. And then you can chart out for people in terms of a bunch of features that describe user behaviors, which I can't tell you unless you come work with me. But trust me that it's a bunch of super cool stuff. You can figure out what are the behaviors that are really good and tend to incentivize people to retain and to acquire. And what are the behaviors that are really bad and we should change the product to get people not to do that so much. And that can be useful for not going out of business. And I assure you that's exactly the kind of thing that's been happening in biology. So this is from an earlier publication of mine where we looked at a bunch of microarray expression data, and we were trying to predict in yeast which genes go up and which genes go down. It's an engineering win and a machine learning win if you get really good predictive models on held out data and you know which genes go up and go down. Yeast biologists don't care. They want to know why. They want to know why did the genes go up and down. And for them that means what are the regulatory sequence elements, right? And then I can sort of get some interpretation about science, like why is this thing behaving the way it does? So that's an example of a prediction problem. Another prediction problem is the New York Times makes physical things and ships them around, right, in the form of dead trees. So there are awesome optimization and learning problems for figuring out how many copies of the newspaper should you be sending to store number 63 in Washington, D.C. tomorrow. Right? Somebody's got to make that decision. Right? And that's an awesome opportunity for machine learning. I can't tell you much about the super cool models that we're doing, but we're trying out all sorts of great models, and I can't really tell you how many monies we're making, but trust me that we can show you that we can make money here. And this is a good one because there's no ambiguity here about why this is good for the company. Like here you have a statistical KPI in terms of predictive accuracy, key performance indicator, sorry, for speaking business. But you also have a money KPI, namely money. Like it's pretty real clear to everybody in the company why it's useful to be able to do that. Another predictive problem is recommendations. So you may have experienced a small amount of personalization on the New York Times homepage. In the lower right-hand corner, there's a little box that suggests stories to you. That's a type of prediction. For doing that, we have a lot of models for doing that. One of them is a model called collaborative topic modeling, which was originally developed by Brown alumnus David Bly, who's now a colleague of mine at Columbia. So I invited him to come give a talk about this model at Columbia, and we're at the New York Times, sorry. And it's now part of our working recommendation engine. So there's a great blog post about this and how collaborative topic modeling can be used to model your audience. These are all predictive problems. What are examples of descriptive problems? Well, one sort of descriptive problem is taking a set of particular users and saying, what are those users reading? Is it meaningful to say something like, what topics are hot in France? What topics are people reading on Android devices in Guatemala? How would you even make that, a legitimate model? And then how would you make that model interpretable? So fortunately for us, we hired somebody away from Brown, Dale Kim, who's very close to getting his PhD. So those of you in the CS department, thank you, Greg. I really wanted to get his PhD. So Dale is now working in my group. Hand to God, I really wanted to get his PhD. And he did that using BNPy, which Eric Sudderth and his group have worked mightily to develop, and developed a set of internal tools, internal web apps for trying to render the audience and make interpretable the question of what are people reading in different places. It's a pretty advanced form of what is generally called newsroom analytics. The tech on which that's built is some fancy pants tech. This is a screenshot from Eric's recent AI stats paper with some fancy pants graphical models. It's great to be able to actually put to work in a place like the New York Times, state-of-the-art machine learning, in order to make interpretable and also make sensible and interpretable to editors a model of what people are reading in different places. And there's some loss functions in there. Ultimately, we're doing optimization. Good. So that's a statement about predictive models and descriptive models. What are examples of prescriptive models? So prescriptive models are when you tell somebody not just, this gene is going to go up, which you often might do in science, or your audience is made up of people who like arts or something, which is a description. A prescriptive model is when you say to an editor, I recommend that you do this particular action. Right? So when you are prescribing to somebody, what is the optimal action for getting some reward given your context? And I said that using a lot of words so that those of you who speak reinforcement learning will know the mindset I'm coming from. You may have heard of examples of steps towards prescriptive modeling in the real world. So in the real world, people learn about prescriptive modeling by doing experiments. So for example, this is an example of an experiment that was done by Facebook where they proved that they could make you sad. So Facebook had this paper from, 2013, where they said, we can do an A/B test, and we can slightly tune which social signals we send to some of you, and we can show that some of you, we can then look at the sentiment of your words and show that we make you sad. It was a tremendous mistake ever to publish this paper. I don't know why they did it. But it's a good example. It's a good example of A/B testing, which is just experiments, like randomized controlled trials, like you would do if you were a scientist. It happens in the real world too. It's just they have a funny name for it. This is what you start doing on the way to randomized controlled trials. And if you're doing it in sort of in the loop, where you make an experiment, you see which one gets a reward, you upweight the weight that's giving you more reward, then you're starting to do something that looks like reinforcement learning. Let me tell you one example of a prescriptive problem we've worked on at the New York Times. One of the problems we worked on was trying to help out a new unit, a post-innovation report unit at the New York Times called the Audience Development Team. So if you ever go look at the innovation report, it starts out like this. Sentence 1, paragraph 1. The New York Times is winning at journalism. Paragraph 2, sentence 1. However, the New York Times is not keeping up with the art and science of getting that journalism to our readers. So the second craft is the craft of audience development. Once the journalism exists, how do we make sure that people find out about that journalism, right? Particularly if they're not buying the dead tree every morning like they used to. So part of that is the intelligent use of social media channels. And if you are doing social media in the newsroom at the New York Times, what is the problem you're faced with? The New York Times puts out hundreds of stories every day. So you've got to keep in your head hundreds of stories. Those stories are shared on the Facebook account, 12 different sub-accounts on Facebook, the Twitter account, 12 different sub-accounts on Twitter, Snapchat, Kik, who knows what Snapchat du jour is going to happen next year. That's a lot of things for anybody to keep in their head at once, right? And you decide which of those stories to share in there's 48 half-hour increments of a day. Who can possibly keep those straight? So they go to a chat room and talk to each other about it. So they go to a chat program called Slack, and they chat with each other about, what should I post on Facebook next? And one of the things that we did is we said, well, let's frame this problem as a problem of trying to optimize reward. And we could look at the prior data, and we could build a predictive model that would predict how well stories would do on social if you promoted it or if you didn't promote it, based on many, many attributes of the story and about many of the attributes of the engagement. And if you can make that prediction, then you can make prescriptions. You can say to an editor, I recommend that you share the following story on the following social channel in the next half hour. Then there begins a product question. So this is not an academic question. For an academic, the problem's over. Like I have a Python script, it runs, it gives you the following AUC, right? But I can't get the editors to fire up Python, and I can't get them to use my Python notebooks, right? So I have to figure out some way to integrate into their process. So there's a product question there, and the editors spend all their day in their chat room, and in particular Slack, which is this particular chat program. So we just built a Slack bot. So we built a Slack bot called Blossom, which is a nice sort of non-threatening name. It's much friendlier than any of the machine learning names I might have given it. It's a nice friendly name for this bot. And they can go to this bot and they can say, Blossom Facebook? Blossom, what should I post on Facebook? And Facebook will say to them in words so that they never need to leave their chat program and open up a fancy web app or open up the command line or something. It'll say to them, here I have the recommendations for you on things that you might put on Facebook next. And where you might put them in different sections, right? And in fact, Blossom actually has another function, which is there's another chat room that they hang out in just for making pitches about, hey, I suggest you pitch this story next. And every now and then Blossom interrupts you and says, hey, this piece is predicted to do really well if you put it on Facebook next. So that's an example of prescriptive analytics. I'm not just telling you, like, there's a 0.9 score for this thing going hot. I'm telling you within a set of actions, there's a space of actions, and I recommend that this action is the action which, given the context that I have now, will maximize some reward. Now, there's sort of like an ontological chain of thought here. When you haven't launched a product yet, and you just sort of know what your market is, you sort of explore that market, and it's a reasonable time for descriptive modeling. Then you launch a product, and you watch people observe it, and you have observational data, and you try to learn something about what are the leading indicators for things that you want from the way people use the product. Eventually, you narrow it down to a small set of covariates, and you might do an experiment. And then once you're doing some experiments, then you're starting to optimize, and you choose the actions that maximize some reward. Then once everything is golden, and you just want the ship to sail straight, then you've decided what your key performance indicators are, and you mail that to senior management as an Excel spreadsheet every morning. Of course, the way a real company works is not like this at all, right? All of these things are happening interactively and iteratively. And in fact, this is the way science happens, right? We tell young people that there's a scientific method, and it starts with a hypothesis. And then you look in the petri dish, and either it turned blue or it didn't blue. And then you publish a paper, and then you go home and, I don't know, have a martini or whatever they did. And when they invented the scientific method. But of course, the way science really works is, just are constantly saying, nuts, this doesn't do what I thought it should do. How do I change the experiment? And you go back and forth iteratively. The real world is like that. It's a mess. So how do you get this done with a data science group? I will tell you a bit about what we've learned about building a data science group in a legacy company. I spent a lot of time reading about pathological bureaucracies. In particular, one pathological bureaucracy that was very useful to read about was the Pentagon. And there's this phrase from a US Air Force colonel that if you really want to change things, you need people, ideas, and things in that order. So I've told you a lot about the things, like the Hadoop and the Python and the Slack. A little bit about the ideas and a little bit about the people, I'll tell you. In terms of the ideas that we think are useful ideas to promulgate inside a company, one is that data science doesn't happen in a vacuum. So you have a data science group, but that data science group cannot work unless you also have really good data engineering. That is, you need to be alongside people who have built an infrastructure to capture every event, an infrastructure to store those events in some format that you can analyze at scale. JSON, S3, Hive, Hadoop, Kafka, Cassandra, all of those words that may seem like things that you don't want to think about or that your database group is working on and excelling, those are things that you need if you want to have a data science group. Right? You can't have a data science group unless somebody has given you the data. And industrial scale, that means you need a good data engineering team. You are not going to have impact if your thing just ends with a LaTeX document with a loss function. If you really want to have impact and you want people to use your stuff, you should sit embedded in their group and see what their process is and figure out how to make your data science end in something that integrates into their process. For example, building a Slack bot. Right? That was a product choice, not a machine learning choice, about how to integrate into their workflow. Data product and thinking carefully about what a product is like. when you're building a data product, like people you may know on LinkedIn or something like that, there's a lot of product mindset that goes into that, which is sort of outside, what bounds you use, or what loss function you ascribe, or what algorithm you choose. Getting this done also includes forming or trying to promote multiliteracies. So multiliteracies is a word from about 10 years ago in the English literature, that is the academic English literature, when English professors were writing about, well, what does it mean to have computationally literate students? So there was idea, you can go read this book by Stuart Selber about multiliteracies for a digital age, I think his book is called, that we can't ask everybody to be functionally literate. We're not really meaning that we want everybody to learn how to code in C++, right? We want people to be rhetorically literate. That means given the output of some sort of computation, you need to know what that means and know how to tell a story with it. And we want people to be critically literate. That is, if I tell you I'm going to use a computer program to build a hoverboard, you should be sufficiently critically literate to say, that is not possible. No, you are not going to write in C++ something that's going to make a hoverboard. That's the kind of multiliteracies we're trying to promote in the New York Times, and I think also there's a lot of room for that in universities, to promote that there's many things that you mean when you say, oh, I want a data literate community. You mean that you want some people to be functionally literate, you want them to be writing Python. You have some people that are critically literate, and you wanted them to know enough about algorithms to know how they're being hoodwinked by algorithms. And you want some people to be rhetorically literate, like I want to be able to give my CEO a chart and have my CEO be able to go on an earnings call and say, well, we have this chart and I know what this chart means. I know how to tell a story with it. Oh, look at that, I put embeds twice. Sorry, I was so excited about embeds. So in my group, there are 6 people, and half of them are really embedded in other teams. And I found that to be extremely useful for making sure that we build something people want. So, in short, I think part of the idea is that really what's changed here is a change in mindset, not just a change in tool set. You go back and read the book Moneyball. I'm told that they made a movie of it later, but go back and read the book Moneyball and you see what's really, the thing that's disruptive there is not, using a different statistical method. It was convincing people that something as ineffable as the craft of picking baseball players could be supplemented by use of lots and lots of data, and just the ability to think quantitatively about that problem. And that is a change in mindset that you also see happening in biology in the mid-90s. Computational social science has totally changed because now, in the 1800s, people thought, oh man, what would it be like if you could actually say who said what to whom, right? And now, you can, right? You can go to Facebook and you can work with Facebook and you can actually get a data set of everyone saying everything to everyone. It's crazy. So now you can go look at those data. Because of a change in mindset, it really pushes a change in tool set. And I'm happy to say that that change in mindset is working at the New York Times. I was happy to see an interview with the CEO of the New York Times a couple of weeks, I guess it was October. He was interviewed about the 5-year plan for the New York Times, and he said, I think what's happened over the last 12 months is a growing understanding from data science and machine learning that time spent is an important measure, and frequency is an important attribute, significant predictor of subscription and retention. The exciting thing for me is the CEO of the New York Times even knows what the phrase machine learning is, right? And is saying it in public. The other day, I heard him actually say latent Dirichlet allocation. It was great. I couldn't get this done without a diverse team. So I've been fortunate to hire and build up a team of people from a diversity of backgrounds: pure math, astrophysics, CS, neuroscience, ad tech, and startups. And part of what we do is embed these people in different teams. Dale is embedded in the new markets team. Dorian's embedded in marketing. Alex is embedded in the personalization team, which builds the recommendation engine. Colin is embedded in the newsroom, and he built the Slack bot. And we can't get this done without people bringing lots of different perspectives to the table and then going out and acting as good ambassadors for data science into these other communities. You need those sorts of culture brokers if you're going to do something really transformative in somebody else's culture. And with that, I'll close, leaving us a little bit of time for questions. Thank you very much.
Thanks so much, Chris. Are there any questions? And if you could, use the microphones.
I'm just going to yell.
Okay.
What happens when engineering takes over the church?
So I don't think that's going to happen. For example, certainly not for my group. For engineering, what makes the New York Times differentiated from other companies? Right, there's any company can write now an algorithm to do gather content from the web, put around 140 characters of aggregation around that content, rewrite their own story, try to get eyeballs on it, and monetize it. Anybody can do that. And that means there's no moat between the New York Times and anybody else for that. And so it would be bad business for us to do that. So personally, I'm not in favor of engineering taking over the church, because any company can start up right now with an awesome engineering team. Only one company right now, at least in 2016, has the advantage that there is a field X such that the people who are the best in that field are at that place, right? So right now at the New York Times, it's like the last independent publisher in the US that has the best journalists, right? So if we do something that actually interrupts the ability of those people to do that, that's bad for business. It's also heretical to the values of the people who work there, and it would be socially disruptive, and it would cause issues. But it's also just bad for business, and so I have no interest in doing that. To come back to the innovation report, the New York Times is winning at journalism, and I don't want to screw with that, right? There's a set of decisions that the company makes every day for which news judgment is relevant. Those are the most important decisions the company makes every day. For the remaining 99% of the decisions that are made in that company every day, there's probably ways to bring data to the table for helping augment those decisions. So it's not the case that state is interested in taking over church. It's the case that I think people are having a much more nuanced discussion about why the wall between church and state went up in the first place, right? Like, you do not want your advertisers exhibiting advertising pressure on the journalism. That is one thing for which you want church-state separation. But for everything else, like making a product that's engaging and gets people to read the stories, it's not necessarily clear that you don't benefit as a company by having people share those lessons from both sides. As Dean Baquet, the new head editor, new since 2014, says, we want our stuff to be read, right? So they want to write good journalism, but they also want their journalism to be read. And there's lots of things that people on the state side can do to help people with that. I think what happens when state takes over church is there's abundant examples of that in journalism today. And you can find many of .coms that have that, but it's not happening at the New York Times. Certainly, I'm not interested in it. Please.
I'll shout as well. The Blossom bot that you mentioned,
Yeah.
that predicts when things go viral
Yeah.
and then to promote them, how does that translate into income for the New York Times? You know you want your stuff to be read, but there is a bottom line. So.
Well, it's double bottom line, as they say in the world. So like a university is a double bottom line institution, right? A university cares about endowment and reputation. And in fact, arguably, reputation is more important than endowment, because if you have a really good reputation, you can probably get a good endowment. So the New York Times, similarly, has a double bottom line in that they want people to trust the content, right? And they want people to find the content engaging, and they also want not to go out of business. So for those projects that we do in collaboration with the newsroom, the KPIs we use are not KPIs with units of US dollars. Right, they're KPIs about engagement and about how do we get people to read our stuff. For the projects that we work on, like optimizing the number of papers that we want somewhere, there the KPI is clearly US dollars. So you're right, like there's an art to thinking about how do we make quantified the qualitative goals about engaging our readers and making sure that our stuff is read, to use the same phrase Dean Baquet uses. The KPIs are less central to the success of a project like Blossom than they are to things like the news vendor problem, delivering papers optimally. Please.
I'd like to ask a question. So I'm not a data scientist, but
Not
I'm
yet.
sort of intrigued by what you mentioned, that there's so much access to data.
Yeah.
And with that, I guess, comes the question, do you ever feel like, or maybe, I guess, in the process of the New York Times, a legacy company, starting to really realize this, like there's too much data, right? Like, or maybe that there's this massive influx of information. Is it ever like maybe that our models are giving us so much, so much information that it's hard to interpret something concrete, or is that ever a problem, or is that not something that I guess is so much of an issue?
Right. So there's two problems with too much information. One is for us as humans, and the other is for us as statisticians. So for us as humans, too much information is a big problem, and we are bombarded by information. And just like every other technological innovation, it will probably take us several decades to learn how to use that technology responsibly, right? Every time some new technology is introduced, like say the automobile, right? Introduction of automobiles by mass production is like 1917, 1914, right? It's not until the 1960s or 1970s you get legislation around seatbelts, right? So generally it takes people a long time to learn how to use new technologies well. And you will have it, you have all of the information in the world in the palm of your hand. It's crazy, right, that you can get in the palm of your hand any information you want. It's going to take us years how not to be distracted by that and learn, again, how to think clearly, right? Like the whole act of just like turning off your phone for half an hour is still like not part of our daily process for most of us. So I do think that there will need to be a sort of information strategizing about how we use information responsibly. For a statistician, the problem is framed as too many hypotheses, right? And in fact, some of the earlier usages of the phrase data mining was in pejorative essays about how people could find any correlations in anything. And that's true. You can definitely find spurious correlations all over the place, which is part of the machine learning mindset. So in the machine learning mindset, you don't search for really good correlations. You search for really good predictive models. How do models predict on held out data? And part of that mindset, that mission accomplished, is about predictive power rather than statistical significance, allows you to incorporate many covariates without not being able to sleep well at night, knowing that you haven't overfit your data. In fact, Rob Shapira in 2005, I heard him give a lecture saying, the central question of machine learning is how not to overfit data. And you're right, like machine learning in general, you're dealing with hundreds or thousands of covariates. That is a central question of how do you take in all that information and still being honest. Part of it is by using predictive power as the figure of merit for any model you build. Please.
Why did you say it was a mistake for Facebook to publish here?
It was a terrible PR move. Terrible PR. I mean, look, A/B tests have been going on for as long as like businesses have existed, right? You have two Walmart stores. One of them you put the beer above the diapers. The other one you put the diapers above the beer, right? Nobody gets morally offended by that, but that's an experiment. But if you publish a paper saying, yeah, we can make you sad, right? I mean, maybe that was exciting for the data science group at Facebook, but it's just terrible PR move, right? Everybody rightly felt manipulated, right? So now, like, Facebook really puts the lockdown on their data scientists. They have to work really, really hard to get permission from CorpCom to go out and give talks. And then you can't videotape it and stuff like that. Dumb move. Dumb. And, I mean, they do A/B tests all the time. Every company does A/B tests. I mean, you go to Netflix, like, they're doing A/B tests on every single person, right? So it's not like there's, like, a big moral mistake in doing A/B tests. Everybody's doing A/B tests all the time. The mistake was bragging about making you sad. That is just dumb. Please.
Sometimes I like to think that part of the role of journalism is to educate the people there.
Yep.
You know, if you agree or not, but if these
Sure.
if these bots are surfacing posts that they think will go most viral, that might tend towards clickbait titles and sort of take away from maybe this ulterior goal to inform the public
Yep.
about these other things that you're writing
Yep.
about that maybe don't have the most viral headlines.
Yep.
Is that taken into account at all, or how do you reconcile maybe that church and state difference?
There's several ways that I sleep well at night. One is clickbait is really a danger if you are an aggregator like HuffPo or Mashable or BuzzFeed, and you ingest content from any old place and repackage it, put a new headline on it, right? The stuff that we're promoting is only stuff that's written by New York Times journalists, right? So like the depth of how clickbaity it can get is not nearly as depth as the arbitrary, like the set of all things on the internet is much trashier than the set of things that New York Times. So like at worst you would get the most clickbaity of New York Times content, which is really not so bad. The other thing is this is not data driven, this is data informed. Meaning what I'm not showing you is that another one of Blossom's features is Blossom Pass. So sometimes editors say to Blossom, what should I post? And the editor says, no, I don't want that. Blossom Pass, never show me that again. And Blossom says, okay, I'll never show you that again. And sometimes the editors type, thanks, which is really fun. Yesterday, one of them typed, gracias. It was just, it's whenever people talk to a bot, you know. These are smart people, but anyways. So I sleep well at night in part because the content is pretty real good content, right? I mean, the clickbait problem is a big problem if you just publish any old thing. But we're only choosing from among a pretty limited set of things. And the other is that we're not literally leaving the editors out. I mean, there's still human beings who are thinking about it and taking that as advice into consideration, but still making a human decision. We're not replacing people. We're trying to make them more efficient and helpful. Again, you can't ask, no matter how good of a journalist you are, like keeping in your head hundreds of URLs, and you don't remember which ones you've posted to which social channels, you just can't ask a human to do that. It's a good place for a computer to be helpful. Please.
How do you market yourselves internally at the Times? And also, how do you teach people to ask good questions?
So teaching people to ask good questions, I think, is something where it's helpful to be a good communicator. I'm on record as saying that I think that part of the skills of a data scientist are to be a good listener and to speak the language of the person rather than asking them to speak your language. And in terms of internal marketing, we just have to be very, very good at what we do. No. In terms of technical marketing, I mean, part of it was choosing problems that you know matter to people. So like the first problem we looked at was subscription cancellations, and that's a problem for which it is unambiguous why that's of interest to the company. Right? That is an important income source. So choose problems that you think people care about, and if you're building something, make sure you build people want. And the way you build people want is the same way you do it in a startup. You go do customer discovery, you ask people what their pain points are, you build them a wireframe, you iterate with them, and I mean, the same sort of lingo you would hear in Silicon Valley is true for data products internal to a company. The only difference is instead of hypothesizing what your market might be, your market is like 5 people, and you can just go talk to them, right? Or 20 people. You can just go ask them what they want. So a lot of that internal marketing is really just making sure that you build something people want, and that you always build, as I say to my group, you should only work on problems such that you could explain to the CEO why this is an important problem. Right? You shouldn't work on problems just because they're exciting to you and like interesting research. You know, work on a problem for which it would be unambiguous to anyone in the company why this is an important problem. Please.
Is there a future in where you not only inform editors and writers and producers of the content what your audience is, describing what the audience is, but you also give them more prescriptive ideas on how to do their work, how to write, what kinds of images, what kind of media to use. Because that's one thing that I see as being part of the future of data science, is it not only going to the, as in, does that make?
Yeah, I know where you're going. So again, I just think that's bad. I just think that would be bad business for the New York Times. Like the New York Times happens to have like 1,300 of the best brains in journalism in the newsroom. And so those decisions that they're making, again, those decisions for which news judgment is relevant, are not the decisions that I want to interfere with. Now the other decisions about like what time of day should you send the email with what subject, alerting people who follow that topic about a new story on those topic, those are decisions for which I feel like data could be brought to the table. But I don't think it's good business for the New York Times for us to use data science to second guess people who have shown that they're really good at thinking about what content would be most engaging to people and what are the stories that really need to be told, what are the stories that in the long term will form a long, stable relationship with readers, which again is also, just to come back to business, if you have a business model around advertising and getting the most clicks, it's a different set of incentives than if your business model around subscription and you want somebody to pay a non-trivial amount of money to stay a subscriber for multiple years. You really want to form a long-term relationship with somebody, and that's very different than getting just one more click.
We'll let her have the last word.
Sure.
Privilege to have this dual perspective for data science, the academic perspective and at the same time it's more practical, industrial perspective.
Right.
Or in your words, the useless perspective and the useful perspective. So do you see any interesting disconnects between what academics are working on whereas what the industry really needs?
Sure. I mean, but that's not new. I mean, that's why academic, so the adjective academic in the real world is often used as a synonym for useless, like for that reason. I mean, a lot of times when you work on something in academia, you're not interested in whether it's useful. And in fact, some people in academia actually like the fact that the stuff they're using cannot conceivably be useful for anything. Go read John Hardy's Mathematician's Apology from pre-World War II, where he brags about how... Sorry?
You're talking about me.
So I'm sure there are people who are alive who are excited about the fact that their things will be useful. So John Hardy wrote this book, Mathematician's Apology, and one of the things he says is how great it is that nothing he does ever could be used, which of course is now the basis for number theory, which is based for all of crypto, right? So little did he know that he would be a hacker. There's plenty of places where there's a gap between industry and academia. I mean, it's less so in fields like engineering where engineering innovations are often driven by interesting problems from the real world. And sometimes it's just a temporal gap, right? Like semiconductors are invented and then that leads to new academic questions, which leads to, quantum computation, which probably won't become, commercialized for a long, long time. So I think there's actually a pretty healthy interplay. It's just that the time scale is often such that you may not know for a long, long time how your work is going to be used. right? I'm a big fan. I like academia. I think it's a good idea. I think it should stick with it.
Okay, let's thank Chris again for an excellent talk.